So in this chapter, we are going to talk about matrix. It's another way of organizing numbers so that we can do calculations faster. So hopefully you watched the video already, and so this the first two sections will be easier. First, let's talk about matrix. It's an array of numbers. Array means that you have a bunch of lists, and they are usually in rows and columns. And so, for example, this is matrix A. And when we talk about matrix, that letter is always uppercase. And in this matrix, you can see that there are some numbers. There are two rows. Rows are horizontal, so you can see that this is a row, and we always count from top to bottom. So the top one would be called row 1, and then the second one would be called row 2. Again, the rows are horizontal. And then after rows, we have columns. Columns always go vertical, and we count them from left to right as well. Left to right. So this is going to be column 1. This is column 2. And the last one is column 3. Okay, so this is a normal matrix. This is kind of how matrix looks like. Now in this matrix, there are 2 rows and 3 columns. So every matrix has a size, and we would read this as 2 by 3. So you say 2 by 3, but when you write it, it's 2 times 3, but you're not actually going to multiply it. You're not going to say 6. We're just going to write 2 by 3. Okay, so let's try the following. Determine the size of the matrices. So let's look at A. How many rows are there? There are 1, 2, 3 rows. And how many columns are there? There are 1, 2 columns. So we would say this is a matrix that is 3 by 2. Okay, so try the next one. So ask yourself, how many rows are there? 2. How many columns? 1. So this is a 2 by 1 matrix. Now, when we talk about a matrix element, it is a number inside the matrix. And it is also defined by the row and column. But we always write it with the lowercase. So for example, A lowercase 1, 2 means it's a number that's inside matrix A. And 1, 2 also means row and column. But we don't put the multiply sign anymore. It's just 1, 2. And that is known as row 1, column 2. Now, how are these elements actually numbered? Well, let's look at this one. This one, matrix A, has 3 rows and 3 columns. So A11 means row 1. Okay, so let's number these. I'm going to just put R for row. So row 1, row 2, row 3, and then column 1, column 2, column 3. So A11 means row 1, column 1. So A12 means row 1. So see how this is row 1 and column 2. Okay, so what do you think this one is going to be? This is still in row 1, but now we're in column 3. So this is called row or A13. Okay, so can you fill in the rest of these with the correct element numbers? Okay, so this is A21, A22, A23, A31, A32, A33. Okay, so let's see if you can get these. This is matrix A. Let's have you pause the video and then go ahead and try to figure out what these numbers are based on the element numbers. And when you're done, just play the video and then you can look at the answers. Okay, did you get the correct answers? So check to see if you made a mistake and whether you matched it to the correct column and row. All right, so given the following, C and D, what is the, if you perform the operation, what would you get? Now, if you watch the video, it should be very easy. So C is 324, negative 140. D is 143, negative 224. And when we add C and D together, we just add the corresponding elements together. So for example, C plus D, in A11, this would be 4. And then the next element would be 2 plus 4, which is 6, and so on. So this should be very easy, just simple addition. Okay, so C plus D looks like this. C minus D is the same, so 3, 2, 4, negative 140 minus 143, negative 224. Okay, so just be careful on subtracting. Okay, 2, negative 2, 1. This is going to be 1, 2, negative 4. All right, let's try this. Given a matrix plus A matrix is equal to another matrix, what is the matrix A? This is very easy. What you want to do is get rid of this, and you get rid of that by subtracting. So this is going to be A matrix is equal to 6, 2, negative 2, 0 minus negative 3, 4, 1, 2. Okay, which is going to be 9, negative 2, negative 3, negative 2. Now let's think about this one, additive identity. If some matrix plus the B matrix is the same matrix back, what do you think B matrix is? So kind of ask yourself, if 5 plus A is equal to 5, what must A be? If you want to get itself back, that matrix better be nothing, right? There's nothing in there. So B has to be the 0 matrix. And it has to be exactly the same size, because if it's not, you can't add them. So B has to be a 2 by 2 0 matrix. And so any matrix added to the 0 matrix must get itself back. Okay, so pretty intuitive, but just we got to put that in there as a property that you need to remember. Now, additive inverse. So kind of go in the other direction. If a matrix plus C matrix is going to give you the 0 matrix, what must be the C matrix? So kind of using the same example. If 5 plus A is equal to 0, what must A be? Has to be negative 5, which means the C matrix must be everything that is opposite of the original matrix. So the C matrix must be 1, negative 2, 2, negative 4. Exactly the opposite in order to get you the 0 matrix. So here's the definition. If matrix A plus matrix B yields the 0 matrix, then each corresponding element must be opposite of each other. All right, so that is all for adding and subtracting matrices. We're going to now talk about multiplying stuff. There are two types of multiplication. One is called a scalar multiplication. So you want to remember the word scalar. Scalar means a number in the matrix world. So we don't really say a number, we just say scalar. So for example, what is 3 times this matrix? Now this 3 part is the scalar part. So usually we would call this the coefficient or the constant. We don't say that anymore. We say scalar. So what is the scalar times the matrix? Very easy. You just kind of distribute it to every single element in this matrix. So this is going to be 15, -3, 9, 21. Okay, let's try this one. 2x, x means a matrix. 2x plus 3 times this matrix is equal to this matrix. What is x matrix? So let's go ahead and just follow our standard operation procedure. So 2x plus, and we're going to multiply first. So this becomes 6, -3, 9, 12 is equal to 8, 5, 11, 0. Okay, in order to solve the x matrix, you would think, how would you solve this if this were not matrix problem? Well, you want to get rid of things that's farthest from x, and that would be this matrix. So we want to get rid of it by subtracting. So 2x is equal to 8, 5, 11, 0 minus 6 minus 3, 9, 12. So 2x is equal to 2, 8, 2, -12. All right, the last thing we want to do is get rid of that 2. So how do we get rid of that 2? We would divide by 2. Okay, dividing by 2 is a little strange because it looks like that. Well, so what we can do is to make it look a little better is to multiply by 1/2. So I'm going to multiply by 1/2 here. So x is equal to 1, 4, 1, -6. So this is the matrix X. So that was one kind of multiplication, which is you multiply by a scalar, easy. The second one is matrix multiplication. So there's a warning here. There are lots of numbers. Please be careful with your multiplication. Do it in your head if you don't think you're going to make a mistake. If you are not very good at doing mental calculation, you might want to use calculator in the beginning because there's just a lot of numbers you want to add and multiply in your head. You may want to just use the calculator. All right. Please follow my steps and try not to do it in your own ways because it will create a lot of problems. Okay, so we have two matrices, A and B. So we want to answer the question, does A times B equal B times A? So let's try it. So hopefully you watched the video and you remember how to multiply matrices. So A times B means the A matrix is on the bottom here, 2, 1, -3, 0. B matrix is up here, -1, 3, 0, 4. Okay, let me just write it in. So this is the A matrix, this is the B matrix. And what happens is you create this matrix. And to create that matrix, you're going to draw some guiding lines. And what you do is you draw a line between the rows and then between the column. That tells me that we're going to end up with a 2 by 2 matrix, and we got to fill these elements in. Okay, so what you do is you take the first element times the first element, so 2 times -1. And then we're going to add to the second element times the second element. So that is 1 times 0. So that is going to give me -2. So -2 goes here. Okay, please be careful with your calculation. Sometimes people kind of do it in their head and then they get 1 times 0 equals 1. So please be careful. Okay, next, 2 times 3. So 2 times 3, and then plus next element, 1 times 4. Okay, so this is 6 plus 4, which is 10. So 10 goes there. All right, and then you do the same thing to fill up the matrix. So -3 times -1 is 3 plus 0, so 3 there. Negative 3 times 3 is 9. 9 plus 0 is 9. Okay, so A times B is going to give me this matrix. Let's try B times A. So I'm going to put B on the bottom, negative 1, 3, 0, 4. And then the A matrix, 2, 1, negative 3, 0. All right. Guiding lines again. Okay, remember this is now, this is now B, this is A. Make sure you line it up and you draw these lines. I know it may seem like it's no big deal, but later on it's going to help a lot. Okay, so let's try again. Negative 1 times 2, that's going to give me negative 2, plus 3 times negative 3, that's going to give you negative 9. So add them together is negative 11. And then we kind of do the same thing. So this is negative 1. This one is negative 12. And the last one is 0. So the question is, does AB equal BA? No, definitely not. AB gives you a totally different matrix from BA, which means that order matters, which is going to be a big deal later on. The order you multiply matters. All right, so let's try another one. Find this matrix times that matrix. Again, the matrix on the left goes on the bottom. The matrix on the right goes on the top. All right, so let's try. Negative 2 times 2 is negative 4. 4 times 4 is 16. And then 1 times, there are no more numbers. So this you cannot multiply. All right, so this is a different size. Now the question is, do I want to set it up every time and multiply a few to realize that I cannot do it? Or is there a faster way? Yes, there is a faster way. So what you want to do is look at the size of the matrix. For example, this matrix here is a 2 by 2. This matrix here is a 3 by 2. 3 rows, 2 columns. In order to be able to multiply, the two numbers in the middle has to be the same. If they are not the same, you cannot multiply. Okay, so let's write that down here. If A is a M times R matrix and B is a R times M matrix, then when the two in the middle are exactly the same, we can multiply. Okay, so for example, this one that we just looked at, 2 by 2 times 3 by 2, that cannot multiply. Now, if you can multiply, then the final matrix is going to be the two ends, M by N. So that gives me the final size of the matrix. Okay, all right, so let's take a look. The matrices that we multiplied up here, A and B. A is a 2 by 2 matrix. B is a 2 by 2 matrix. So first, take a look at the middle two numbers. They are the same, so we can multiply. And the question is, what kind of size will it yield? Look at the two ends. It will yield a 2 by 2. And then here we just kind of want to say the same thing. The product matrix AB exists only if A is M by R matrix and B is a R by M matrix. What we're trying to say here is that the two numbers in the middle have to be the same. Okay, and then that's it for the lesson today. Go ahead and just do your homework. And try to kind of go through the lesson to see if you have any questions.